Hi future GISPs! I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to study the 210 websites, 1,155 book pages, 1,700 Quizlet flashcards, and 291 videos and podcasts included in the GISCI's recommended study material like I did when I passed the GISP exam. In this video, I'm going to teach you everything I learned about managing, documenting, and communicating GIS work to easily pass the GISP exam. Knowledge of managing, documenting, and communicating GIS work is the third section, under the Professional Practice Knowledge category of the GISP exam blueprint. Let's get started. This topic sits where general project management, IT project management, and GIS&T project management all overlap. The GISCI draws heavily from the Project Management Body of Knowledge, or PMBOK, and the GIS&T Body of Knowledge, or GIS&T-BOK. So understanding how these two worlds connect is key. The PMBOK provides the universal project management structure. Process groups, knowledge areas, planning methods, risk control, documentation standards, and communication frameworks that apply to any professional project. The GIS&T body of knowledge, on the other hand, provides the domain-specific technical content for geospatial work. Data models, spatial analysis, cartography, geocomputation, system design, and the technical skill sets needed to execute GIS projects. The GISCI merges these two worlds by expecting professionals to manage GIS projects using PMBOK's project management discipline while applying the GIS&T's technical expertise to the actual geospatial tasks. First, let's discuss the project lifecycle. The project lifecycle is a standardized framework developed by the Project Management Institute. It describes how any project progresses from start to finish. It consists of 5 process groups: initiating, planning, executing, monitoring and controlling, and closing. The Project Management Institute, or PMI, is the world's leading professional organization for project managers. It develops project management standards, publishes the PMBOK Guide, or Project Management Body of Knowledge, and administers globally recognized certifications. A process group. A process group is a related set of activities that apply to each phase of a project. The initiating process group. Initiating defines a new project or phase. Initiating processes can include identifying stakeholders, confirming alignment with the organization, justifying the work with a business case, and authorizing it with a project charter. The planning process group. Planning develops a blueprint for scope, schedule, budget, quality, risk, procurement, communications, and human resources. The plan becomes the baseline for execution and control. The executing process group. Executing is where work actually happens, building datasets, apps, maps, and documentation, coordinating people, technology, and processes. Monitoring and controlling process group. Monitoring and controlling track progress against the plan, manage changes, control scope, time, and cost, and handle risks and issues. Techniques like earned value management help compare planned versus actual performance. The closing process group. Closing formally finishes a project or phase, obtains acceptance of deliverables, archives documents, and captures lessons learned for future projects. Together, the 5 process groups, initiating, planning, executing, monitoring and controlling, and closing, form a complete roadmap for managing any project from start to finish. Understanding how these groups interact ensures that GIS projects are launched with clear direction, carried out efficiently, tracked effectively, and wrapped up with proper documentation and evaluation. By following this structured lifecycle, GIS professionals can deliver more consistent, predictable, and successful project outcomes. Now let's take a look at project management knowledge areas. The project management knowledge areas were created by the Project Management Institute as a universal framework to standardize how projects are planned, executed, and controlled. The project management knowledge areas organize what needs to be managed. The project management knowledge areas are project integration management, project scope management, project schedule management, project cost management, project quality management, project resource management, project communications management, project risk management, project procurement management, and project stakeholder management. Let's take a look at project integration management. Project integration management ensures all parts of the project work together. It includes creating the project charter, developing the project plan, overseeing changes, and making sure everything stays aligned with the project's goals. Project scope management. Project scope management defines and controls what work is and is not included in the project. This includes gathering requirements, creating the scope statement, and managing scope creep. Project schedule management. Project schedule management plans, develops, manages, and controls the project timeline. It involves defining activities, estimating durations, sequencing tasks, and using tools like Gantt charts and critical path analysis. Project cost management. Project cost management plans and controls the project budget. This includes estimating costs, determining the budget, and managing expenses to stay within financial limits. Project quality management. Project quality management ensures that the project's deliverables meet required standards. It involves quality planning, quality assurance, and quality control activities. Project resources management. Project resources management manages the people, equipment, and materials needed for the project. This includes team development, workload management, and resource allocation. Project communications management. Project communications management ensures information is planned for, distributed, stored, and communicated effectively. This covers stakeholder communication plans, reporting, meetings, and feedback loops. Project risk management. Project risk management identifies, analyzes, and responds to project risks. It includes risk assessment, qualitative and quantitative analysis, and developing mitigation or contingency plans. Project procurement management. Project procurement management manages acquiring products, services, or results from outside vendors. This includes drafting contracts, selecting suppliers, and managing vendor performance. Project stakeholder management. Project stakeholder management identifies stakeholders and manages their expectations and engagement. It ensures stakeholders are informed, supportive, and aligned with the project's goals. Understanding the 10 project management knowledge areas provides a complete framework for planning, managing, and guiding any project from start to finish. Whether you're deploying an ArcGIS enterprise, redesigning a geodatabase, developing web applications, or coordinating county-wide data initiatives, these knowledge areas help ensure that GIS projects are delivered on time, within scope, within budget, and at the highest level of quality. By applying these principles, GIS professionals can bring structure, clarity, and accountability to their work, leading to stronger outcomes and more successful project delivery. Now let's take a look at GIS program management. A GIS program. A GIS program is an ongoing effort that uses GIS to support an organization's mission and business processes over the long term. A GIS project. A GIS project is a temporary effort that uses GIS to create a unique product or service, like a new dataset, app, analysis, or map series. The program-project relationship. A GIS program often launches and supports multiple projects, like database development, software migration, custom app development, outreach products, and integration with other systems. Project portfolio management. Project portfolio management looks at multiple GIS projects together and ensures they align with program goals and overall organization strategy. The organizational environment. GIS projects live inside real organizations: public agencies, utilities, private companies, nonprofits, and universities. Each has its own politics, priorities, constraints, and user communities that shape how projects are planned and managed. A GIS strategic plan. A GIS strategic plan defines purpose, vision, goals, objectives, scope, and priorities for a GIS program and its projects. Deliverables. Deliverables are the concrete outputs of a GIS project. Things like strategic plans, database designs, technical specifications, applications, data products, orthoimagery, LiDAR, training materials, and map products. Now let's take a look at the types of GIS projects. Common GIS project types include new or expanded GIS program development, GIS database development or enhancement, custom GIS application development, software or hardware acquisition or migration, GIS integration with external systems, standards and policy development, outreach, training, or educational product development, and special on-demand GIS service products. A good project manager will ensure the quality of a project's products. Quality is how well project deliverables meet requirements. In GIS, this often involves data accuracy and completeness, positional accuracy of imagery and elevation data, and standards compliance. Important GIS-related standards bodies include the Open Geospatial Consortium for Geospatial Data and Services, the Federal Geographic Data Committee for Data and Metadata Standards, the American Society for Photogrammetry and Remote Sensing for Imagery and LiDAR Accuracy, the International Standards Organization for Geographic Information Standards, and EURISA and its GIS Management Institute for Best Practices. Now let's discuss the difference between quality assurance and quality control. Quality assurance is proactive. It focuses on preventing problems before they occur by creating processes, standards, and workflows that ensure work is done correctly from the start. Quality control is reactive. It focuses on finding and fixing errors after the work has been produced, by inspecting, testing, and verifying outputs. Managing risk is another aspect of project management to be aware of. A risk is an uncertain event that could help or hurt project objectives. Common risk response strategies include avoidance. Avoidance changes the plan to remove the risk. Transference. Transference shifts the impact to a third party. Mitigation. Mitigation reduces the probability or the impact of the risk. Acceptance. Acceptance is acknowledging the risk without special action. Risk registers and probability impact matrices help prioritize risks and plan responses. A risk register is a central project management document that lists all identified risks on a project, along with their likelihood, potential impact, and the strategies for preventing or responding to them. A probability impact matrix, also called a risk matrix, is a project management tool used to prioritize risks by plotting two things: how likely the risk is to occur, or probability, and how bad the consequences would be if it occurs, or the impact. The probability is plotted on one axis of the chart, and the impact is plotted on the other axis. Those two dimensions are plotted on a grid, and the intersection gives each risk a priority level: low, medium, or high. Now let's take a look at some other project management concepts. Project Charter. A project charter officially authorizes the project and documents objectives, stakeholders, scope at a high level, and the commitment of resources. Pre-planning. There are some foundational elements that should be established before planning the detailed methodology of a project. Before detailed planning, successful projects must establish the organization's mission and business processes, the current situation and baseline, requirements for the project results, high-level description of scope and stakeholders, and internal support, sponsor, and assigned charter or equivalent. An oversight committee. Projects may be directed by an oversight committee. The oversight committee reviews deliverables, budgets, and major decisions, and helps resolve resource and participation issues. An oversight committee could include a project manager, members of the project team, project sponsors, and representatives of stakeholder departments and external partners or contractors. A project manager. A project manager leads the team, coordinates resources, manages stakeholders, and is accountable for delivering results. Resources. Resources are people, money, equipment, software, data, and facilities used to complete project work. Stakeholders. Stakeholders are individuals, groups, or organizations that participate in, influence, or are affected by a GIS project or program. Direct costs and indirect costs. Direct costs are tied directly to the project. Staff time, software, hardware, travel, and contractor invoices. Indirect costs, or overhead, are organization-wide expenses, like rent, utilities, and general administration. Indirect costs are often rolled into billing rates as a multiplier. Earned Value Management, or EVM. Earned Value Management combines scope, schedule, and cost to measure how the project is performing against the plan. It compares planned value, earned work, or work accomplished, and the actual cost. This helps identify if you're ahead or behind schedule and over or under budget. Procurement management. Procurement covers acquiring software, hardware, consulting, imagery, or data services. GIS projects may use RFPs, RFQs, bids, or sole source contracts, and must manage contract scope, deliverables, and performance. The triple constraint. Scope, time, and cost are often called the triple constraint. Changing one affects the others. Now let's take a look at documenting GIS work. Metadata. Metadata documents the who, what, when, where, why, and how of GIS data, so others can understand and reuse it. Project documentation can include requirements and use cases, system and database designs, workflow diagrams and SOPs, scripts, models, and configuration notes, and test plans and results. Documentation repositories. Central repositories store project documents, metadata, designs, reports, code, and decisions so future staff can find and understand past work. Lessons learned documentation. Lessons learned capture what went well and what didn't, so future projects benefit from past experience. And now let's take a look at how to communicate project progression. Project communications management. Communication planning determines who needs what information, when they need it, and how they will receive it. Project updates. Status updates report progress, milestones, issues, and next steps to sponsors, stakeholders, and team members. Visualization. Maps, dashboards, charts, and infographics turn complex GIS analysis into something that non-technical stakeholders can understand quickly. Presentations. Presentations use storytelling, problem approach, results, and implications to communicate how GIS supports decision-making. Feedback mechanisms. Surveys, workshops, review sessions, and comment periods allow stakeholders to give feedback that can improve data, applications, and workflows. A work breakdown structure, or WBS. A WBS is a hierarchical breakdown of the project into smaller, manageable tasks. It drives scheduling, cost estimates, and tracking. A Gantt chart. A Gantt chart is a visual schedule where tasks are displayed as horizontal bars showing start and end dates, dependencies, and progress. Task predecessor. Predecessor relationships show how one task depends on another. The critical path. The critical path is the longest chain of dependent tasks that determines the shortest possible project duration. Those are all of the concepts that I learned about managing, documenting, and communicating GIS work in preparation for the GISP exam. Managing, documenting, and communicating GIS work is where technical GIS skills meet professional practice. On the exam in real life, you're expected to understand how GIS programs and projects fit into organizations, how to plan, schedule, and track GIS projects, how to manage scope, time, cost, quality, risk, and stakeholders, how to document GIS work so it's reproducible and maintainable, and how to communicate results clearly to decision makers and the public. Master these concepts, and you'll not only be ready for Section 1003, you'll be ready to lead GIS work at a professional level. Now you know everything I learned about managing, documenting, and communicating GIS work to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so I can keep helping people pass the GISP exam and build the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is a comprehensive, easily understandable, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.